Welcome to a video on further binomial expansions. So recap from the previous video where we did binomial expansions, but this time instead of doing 1 plus x to the power of something, so where the n value helps us with our coefficients from Pascal's triangle, we're going to now use x plus y. So both the first and the end term will be affected. So as we move through, x plus y to the 0, anything to the 0 is just 1, so that's that first row. Anything to the power of 1 is just itself, and you can see your coefficients of 1 and 1 actually work. When it's squared, you get 1x squared plus 2xy plus y squared. For the power of 3, so when it's cubed, n equals 3, from that row, your coefficients are 1, 3, 3, 1. So you get 1x cubed plus 3x squared y plus 3xy squared plus y cubed. You will notice that the first term in the bracket, its powers are going down, and the second term in the bracket, its powers are going up. But the coefficients stay the same. They're from the Pascal's triangle. So the next one is when you have x plus y to the power of 4. So you have a go at this one first. Make sure you have your coefficients of from Pascal's triangle, 1, 4, 6, 4, 1. And make sure that your first term in the bracket, the x, starts at the highest power, and the y's, and it decreases the x's, and the y's, they increase until you get y to the 4 at the end. So you should have got x to the 4 plus 4x cubed y plus 6x squared y squared plus 4x y cubed plus y to the 4. One final one for you to have a go at. Once again, use the Pascal's triangle, the row, n equals 5. And remember, x coefficients go down, x powers go down, y powers go up. So for this one, you should have got x to the 5 plus 5x to the 4y plus 10x cubed y squared plus 10x squared y cubed plus 5x y to the 4 plus y to the 5. Two examples. So similar to the previous video, we are going to look at now if we replace the x's and y's. So we're just going to use the coefficients from Pascal's triangle and relate them to the expansions that we've just looked at. So for our first one, because it's a cube, from x plus y cubed, this is what we got, x cubed plus 3x squared y plus 3xy squared plus y cubed. We're going to replace the x's with 2x and the y's with minus 3y. And you can see that I have done that in each of the steps. And so when you expand those, you get 8x cubed minus 36x squared y plus 54xy squared minus 27y cubed. Find the term independent of x for this expansion. So because it's to the power of 4, we're going to use the 1, 4, 6, 4, 1 row of Pascal's and use our expansion. So this will be 3x all to the 4 plus 4 lots of 3x all cubed times 2 over x plus 6 lots of 3x all squared times 2 over x all squared plus 4 lots of 3x times 2 over x cubed plus 2 over x to the 4. Now as you practice these, you'll become better at identifying which terms are going to be independent of x, so you won't have to do the whole expansion. But we'll do it for this one. And so you get 81x to the 4 plus 108x cubed, lots of 2x plus 54x squared times 4 over x squared plus 12x lots of 8x cubed plus 16 over x to the 4. Simplifying that, you get 81x to the 4, 2 plus 216x squared plus 216 plus 96 over x squared plus 16 over x to the 4. And therefore the term that's independent of x is 216. Thank you.